Before we start talking about light sensors, we're going to give a little bit of background on our project. The way a solar cooker works is energy from the sun comes down and bounces off reflective material into either a box or a more popular parabolic dish type. The light bounces around the dish to one focal point that strengthens the sun's rays enough to cook food. These parabolic-style solar cookers have been becoming more popular over the years, with people using them as a way to cook without electricity or gas, making it ideal for rural areas in Africa or Asia, where people don't have access to such things. The solar cooker is relatively easy to use. Just point towards the sun and cook your meal. But what if someone wanted to cook a meal in less time, being more efficient? They would need to know what the best angle was to point the cooker towards the sun, where the cooker would receive the most energy. Our original plan was to build a solar cooker, but upon second thought, we decided to build something that could be used in unison with the solar cooker. We went back to our design question: how would we make a solar cooker more efficient? Using this question, we decided to make a light intensity sensor. The light intensity sensor would allow the user to know what angle relative to the sun the solar cooker should be pointed at, allowing the most energy to cook meals with. We are striving to make a module that would read the light intensity so you would know where that angle is. For our project, we are looking to make a simple sensor that would detect only a significant difference in light. We found a schematic for such a light sensor on the internet that used a lot of components we already had, such as a breadboard, wires, and resistors. What we didn't have was a 10K variable resistor, an LDR, or an 8-pin quad comparator. This is how the whole thing works. The LDR senses light exposure. When it isn't exposed to light, it sends a signal to the comparator, then switches to a second set of wires that turns on an LED, letting the user know the light is weak. Purchasing the parts, we put together the circuit board. Unfortunately, it didn't work. We were unable to tell what part wasn't doing its job, or if something was hooking up incorrectly. We tried switching out parts, switching out boards, we tried different batteries and different LEDs. Nothing seemed to work. If we had more time, I would try a different setup with different components, maybe buying all new parts to make sure they work properly. If I had maybe a month, I would even try to implement a sensor that would actually give you a numeric value for the light intensity, and also make a solar cooker to test it with.